So this is on x and y intercepts. Remember that the x-intercept is where the line of your equation intersects the x-axis, and the y-intercept is where it intersects the y-axis. So when I'm talking about the x-intercept, what I'm really saying is that it's the point where we have some value for x, but 0 for y. Because any point on the x-axis has a y value of 0. So what we're going to do is, to find the x-intercept, we're just going to plug in that 0 for y. So we look at our equation and it's 2x minus 5y equals 10. So we're going to replace the y with a 0. 2x minus 5 times 0, because we're replacing that y with a 0, equals 10. So when we replace the y with the 0, we get 5 times 0, which is 0. So this whole term really cancels out. What we're left with is 2x equals 10. And then if we divide both sides by 2, we get x equals 5. So when y is 0, x is 5. So that gives us the point 5, 0. And we're going to plot that. So we go over to x is 5, y is 0, and we plot that point. Now remember, that was the x-intercept, and we can see that that point lies on the x-axis. Now we're going to do the same thing for the y-intercept. So we start with the same equation, 2x minus 5y equals 10, and to do the y-intercept, that's where we have some 0 for x and then some value for y. So it's the exact opposite of the x-intercept. So we're going to plug in x is 0 this time. So 2 times x, which is going to be 0, minus 5y equals 10. And this time the 2 times 0 is what's going to cancel. And what we're really left with is negative 5y equals 10. So we divide both sides by negative 5, and we get y equals negative 2. So that tells us when x is 0, y is negative 2. So now we plot that point. We go to x is 0, which is the middle, the origin, and then down to y is negative 2. And now that we have our x and y intercept, we can draw our line. So now we're looking at example B, which is 3y equals negative 5x. And automatically you should notice that this one looks a little different. In example A, we had 2x minus 5y equals 10. Remember, 10 is called the constant term. There's no variable attached to it. In example B, you'll notice there is no constant term. And that should be our first clue that the x and y intercepts are both going to be the origin, the point 0, 0. But if you don't recognize that, that's fine. We'll start this problem off just like we did the last one. We've got 3y equals negative 5x, and we'll find the x-intercept. So x-intercept is some value for x, 0 for y. So that's 3y equals negative 5. Oops. Let's go backwards, because remember, this 0 is our y. So let's plug our 0 in here. So 3 times y, which we're replacing with 0, equals negative 5 times x. Now 3 times 0 is 0, so we've got 0 equals negative 5x. And then to solve for x, we would have to divide both sides by negative 5. Well, 0 divided by negative 5 is 0. 0 divided by any non-zero number is 0. So when y is 0, when we plugged y in as 0, what we got was x is also 0. So remember, the point 0, 0 is the origin. Well, that also means that if we plug in x is 0, we're going to get y is 0. They're going to be the same. If you don't believe me, go ahead and try finding the y-intercept, and you'll find that the y-intercept is also 0, 0. So now we know the x and the y-intercept are the same point. They meet right in the middle at 0, 0. The problem with a situation like this is that you cannot graph an equation if you only have one point. So you're going to have to choose another one. So if I look at my equation, 3y equals negative 5x. I can choose to let x be any value that I want. I could also do the same thing for y. But there's a very, very easy point to choose, and that is the coefficient that's attached to your y value. If I plug 3 in for x, then what I'm doing is I'm guaranteeing that I have something that's divisible by 3. So I'm going to say, okay, let's find out what happens when x equals 3. So I take my equation, 3y equals negative 5x. I'm going to plug in x as 3. So 3y equals negative 5 times 3. Negative 5 times 3 is negative 15, so 3y equals negative 15. And now to solve for y, I have to divide by 3. But I've already given myself something that's divisible by 3. So y equals negative 15 divided by 3 is negative 5. So remember, when x is 3, that's what we plugged in. Our output was y is negative 5. So now we have another point, 3, negative 5, and we're going to graph that. So we go to x is 3, and then down to y is negative 5, and we put our point. And now we have our 2 points, and we can go ahead and draw our line through those 2 points.